to my channel. I am SN Kovendra from SVC. My USN is 1B22CS 133. I am from Dev section, branch CSE. Now course is Mathematics 2 for CSE stream. Course code BMATS 201. And the topic is Exploring Vector Space in Mathematics. Let's start. Definition of vector space. A set of all ordered n tuples x1, x2, so on until xn, where x1, x2, so on until xn are real numbers. An n tuple is called a vector, and the numbers x1, x2, so on until xn are called components of the vector. Vector addition. The vector addition operation combines any two vectors to produce a third vector. Scalar multiplication. Scalar multiplication scales a vector by a scalar, also known as a scalar field. Properties. Vector addition and scalar multiplication must follow specific properties to be considered vector spaces. Formula and examples of vector space. Formula. The formula for vector space V is V equals to set of V1, V2, V3, so on until Vn. Example. Example of vector space include the set of all n cross m matrix over a field and a set of all polynomials with coefficient in a field. Condition for vector addition and scalar multiplication. Vector addition. To satisfy the condition of vector addition, the sum of any two vectors in a vector space must also be in a vector space. Scalar multiplication. For scalar multiplication, any scalar multiplied by a vector in the vector space must also be in that vector space. Properties of vector space. Associative property. The associative property holds for both vector addition and scalar multiplication. Additive identity. There exists a unique vector called the additive identity, which when added to any vector does not change its value. The additive identity is 1. Additive inverse. For every vector in a vector space, there exists a unique vector called additive inverse, which when added to a vector gives the additive identity. Distributive property. The distributive property of scalar multiplication over vector addition holds for all vectors in a vector space. Basis and dimension of vector space. Basis. The basis of a vector space is a set of linearly independent vectors that generate the space. Dimension. The dimension of a vector space is the number of vectors in the basis of the space. Operation. Certain operations such as projection and change of basis require knowledge of the basis and dimension of the vector space. Application of vector space. Vector space theory is applied in linear algebra, physics, and computer graphics. Machine learning employs vector spaces and its core for concept extraction, image recognition, and language processing. In economics, the study of vector spaces can help researchers understand various complex financial modules. Problems on vector space. The problems on vector space generally involve determining whether a given set of vectors forms a basis, finding the coordinates of a vector relative to a basis, and determining whether a linear transformation is injective or surjective. Example problem. Let V equals to set -1, 0, 2, 3, and -6. Next, W equals to 1, 0, -2, 3, 6. And set U equals to 3, 7, -6, 2, -1. Calculate A U plus V, B V plus U, C V plus W, D 3U plus 7V. So there are 4 subparts in this question. The solution is given for each subpart. So let's start with A. So A, the question asked is U plus V. So the set U consists of 3, 7, -6, 2, -1. And set V consists of -1, 0, 2, 3, -6. So here it's represented as 3 comma 7 comma minus 6 comma 2 comma minus 1 plus minus 1 comma 0 comma 2 comma 3 comma minus 6. And so when we add both the vectors, we get equals to 3 plus of minus 1 comma 7 plus of 0. So here we are adding first term with the first term and second term with the second term of both the vectors. The first vector with the second vector. X minus 6 plus 2 comma 2 plus 3 minus 1 plus of minus 6. So the answer is 2 comma 7 comma minus 4 comma 5 comma minus 7. Next, for the V part, the question is V plus U. V set consists of minus 1 comma 0 comma 2 comma 3 comma minus 6. So plus of 3 comma 7 comma minus 6 comma 2 comma minus 1, which is set U. So the answer is 2 comma 7 comma minus 4 comma 5 comma minus 7. Next question. C. V plus W. So the V set. It consists of minus 1 comma 0 comma 2 comma 3 comma minus 6 plus of 1 comma 0 comma minus 2 comma minus 3 comma 6. So here all have different signs. So we get the set 0 comma 0 comma 0 comma 0 comma 0. So here they've asked 3 times u plus 7 times v. So we are going to multiply 3 with all the elements of set u and 7 with all the elements of set v. So we get this set as 9 comma 21 comma minus 18 comma 6 comma minus 3 for 3u plus minus 7 comma 0 comma 14 comma 21 comma minus 42 as set 7v. And when we add both the sets, we get equals 2 comma 21 comma minus 4 comma 27 comma minus 45. Conclusion. Summary. Vector space is an important concept in mathematics that is useful in wide array of contexts from physics to economics. Importance. The properties and characteristics of vector spaces facilitate problem solving and modeling complex systems. Thank you for watching. Do like and leave a comment below in comment section. Thank you.